we welcome your attention to this rare and curious invention, full of wonders and mysteries to unlock. We think you'll find it grows your mind, our science in a box. Science in a box, science in a box. The show's begun, let's have some fun with science in a box. Thank you everyone for coming. This is Fusion Science Theater's Science in a Box. I am the scientist here, and this is my assistant, whose name is Vinnie White. And this is Vinnie's magical box. I don't know about that. Now, all the boys and girls, do you all have a ballot? Do you have a green one and a blue one? Here's what I want you to do. I want you to sit on them, okay? But I don't want you to sit on the pencils, okay? Just sit on the ballot, and we'll let you know what to do, okay? Sit on those. And as you already know, we're taping the show, so if for some reason you don't want to be on camera or you don't want your child on camera, then you should, sort of move back and grab them if they start to come up. Okay, so I've talked to some of you earlier, and you said you came willingly. So, does that mean you like science? Tell me if you like science. You like science? Because today, great. So today we're going to do some science. We're going to do some science about a very mysterious substance. This substance is so mysterious. 70% of the Earth's surface is covered by this substance. 70% of our body is this substance. Does anybody know who this substance is? Do you know? What do you think? Water, exactly. This mysterious substance that you just named is indeed water. Vinnie, what are you doing? You're an actor. Vinnie, we're going to be doing some science today, and we're going to be talking about water, and it's very, very small. The particles are so small, we can't even see them, so I don't really think we need an actor. Oh, so Vinnie says that's why he needs to act things out, because things are so small. Okay, fine. That's fine. All right. So, it's very, very mysterious, this water. In fact, I have a sample of water right here in this pot, and it's doing something very mysterious. I bet you've never seen this very mysterious thing happening before. Have you? Have you seen it? Never? Allison, what's it doing?
Boiling.
Boiling? How do you know it's boiling? Tell me what you see to make you think it's boiling.
It's bubbling.
Bubbling. Dixie, what do you think?
Smoke.
Smoke. Who else has something that they see that makes them think it's boiling? Somebody else have something? Dixie, what else do you see?
Well, it's like moving around.
It is. It's jostling in here, right? So we have bubbles, we have smoke, and moving around. That's fabulous because we're going to do science together, right? And what you've just done are called observations. The very first step to doing science is making observations, okay? So, observations. Can you put on your observation glasses for me, folks? Come on. Observations. You too. Observations. We're making observations. And we hear, and we see, and we smell things. We have some observations. So the next thing we do after science, you want to know the next thing? What's the next thing we do, Vinnie? That's right. The next thing we do is we ask questions, okay? So we've made some observations. Let's see it. Good. Now we ask questions. All right. And let me see. What kind of question, does anyone have some questions that we could ask? I don't know. Questions? 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 Vinnie, do you have a question? Okay. Can everybody help us read this question that Vinnie has? Okay, together. Let's go. What happens to water when it boils? Okay, what happens to water when it boils? That's a really good question, but I'm going to have some trouble because here's the problem. Remember I told you that water is made of tiny, tiny little pieces and you can't see them? And this is a problem we have all the time in science. It's so small, we can't see them, so it's hard to talk about them. They're so small that you can't see them. Oh, Vinnie. Oh, gee. Oh, thank you. You know what Vinnie brought me? Is he brought me a model. Okay? Now this isn't really a piece of water, it's foam, right? But we're going to use this thing we can see to represent the particles we can't see. And this is one piece of water. And does anybody know the name of one piece of water? Can we just hear it here? What do you think, Zizi? It is foam, indeed. But what do you call, you're absolutely right, but what do you call the smallest piece? What is this, Dixie?
A drop.
Well, it's actually even smaller than a drop. Can you believe it? Carter?
Molecule.
It's smaller than a drop. It is one piece, it's a molecule. Let's hear it. It's a molecule. And you can see how many pieces are in this one molecule. Count them.
1,
3, and 2 of them are the same, and 1 of them is different, okay? So these 2 are hydrogens, this is an oxygen, and you know, you don't make water by just putting hydrogen and oxygen together and whizzing in the blender. They're together by strong chemical bonds. Not really Velcro, but strong chemical bonds. So here they are. It's a perfect model of water. Thank you very much. And what's the formula for water? Wow, great, you're really smart. That's fabulous. Good, okay, great. So we've learned something. Thank you very much. Yes, what do you want? Oh, okay, so the question, would you like to know what happens to water when it boils? Would you like to know? Would you like to know? Well, I'm not going to tell you because the whole purpose of doing science is not for me to tell you, it's for us to figure it out together, right? So what we're going to do is I'm going to tell you some possibilities, some reasons why, what is a good reason water might boil. Now I want you to listen because then I'm going to ask you what you think, okay? So listen up. Here we go. These are called hypotheses. This is a hard word. Can you say it? Wait till... Oh, that was good. Let's do it all together. Hypotheses. And this is how we're doing this one. Okay, so do it with me. Hypotheses. Excellent. All right, okay, here's some hypotheses. Individually, they're called hypothesis. Here we go. Maybe this is hypothesis number 1. Maybe what happens to water when it boils is, well, you know, if you wait long enough, the level goes down, right? So maybe what happens to water when it boils is it just disappears. That's hypothesis number 1. Water disappears. Here's another hypothesis. Maybe what happens to water when it boils is that it's together when it's in a liquid, but maybe what happens when it boils is it all spreads out. Woo! That's hypothesis number 2. Here's hypothesis 3. Remember those strong bonds I was telling you about? Remember the ones that hold together the hydrogen and the oxygen? Maybe what happens when water boils is those bonds actually break. Like so. They break up, maybe they have hydrogen and the oxygen, and they're separate. That's hypothesis number 3. And you know what? Maybe you're thinking, well, I don't know if it's 1, 2, or 3. I don't know. And it's always okay in science to say you don't know. Always okay. So maybe that'll be what you choose. Now, I want to know what you think. And how will you tell me how you think? Do you think? What? Oh, he says, He says we have a ballot here. You have a green ballot? Everybody have a ballot? Okay. So get out your ballot and tell me if you're a boy or girl. You can circle that.
I did that.
Oh, you're so smart. Great. So tell me if you're a boy or girl. Tell me your age. Some of you already told me your age. And then I want you to think about it. Think about whether it's hypothesis number 1, disappears, 2, spreads out, 3, breaks up, or 4, I just don't know. And say what you think, okay? Now, parents, you can help your child. Nobody's helping their child. That's okay. I was going to say you could, but you had to tell us your age then. We want to know what you think. And do we have a ballot box around here? Excellent. We have 2 ballot boxes. Would you be so kind? Don't put your pencils in yet. Just put the green ballot in when you're done. Are you done? Good. Perfect. You tell us what you think? Okay. It's a secret ballot. Why are you sitting on the blue one? So you don't, like, rip it up. That's why. Yeah. Come on. You think it disappears? Oh, good. Good. We have a little coaching here by MITC chemistry instructor, Bill. There's a little coaching going on here. No.
Do not let him influence your vote. How old are you? Down to 2. Okay, you put down 4. You write a 4?
Did you guys all vote last week? Did you vote? No? Oh, that's right. But you got to vote today at least. Right? That's good. I'm glad. Thank you very much. What? Oh, okay. So Vinnie wants to know. Do you want to know what happens to water when it boils? Okay. You want to know? I'm not going to tell you. Do you know why? Because in science, when we're trying to figure something out, the next thing we do is we do experiments. Okay? Would you like to see some experiments? Would you like to see some experiments? Okay, all right. So what I'm going to do, first of all, before I do the experiments, is I'm going to put on this eyewear. Now, can anyone tell me why I put these on? Yes, easy.
Because you don't want the stuff that you're doing in your eye.
I don't want the stuff that I'm doing in my eye. Dixie, what do you think?
You don't want to it to hurt your eye.
I don't want it to hurt my eye, but has anybody mentioned how good I look with these on? What do you think? Dixie, do you think I look good? Oh, thank you. You're very kind. Thank you. That's a good, yeah, thank you, that too. So here's what I'm going to do. Before you came in, when you were all streaming in, I was upstairs in our laboratory upstairs, and I made some hydrogen and some oxygen, and then I put them together. Now, this is not water. This is hydrogen and oxygen in this tube, okay? Now, what I'd like to do is I'd like to test this hydrogen and oxygen and see what happens when I put it over the flame. We're all going to have to do our observing, right? We're going to have to do our observing, and I would like you to be able to tell me what happens. So let's see. Hydrogen and oxygen. Did you hear anything? Yeah. Did you hear anything? What'd you hear? Lucinda, what'd you hear? Just a pop? Okay, did you see anything?
Yeah.
You did. Flame went out. Dixie, what'd you see?
I thought that it like disappeared.
It did.
Right away.
Yes. When we do things in science, sometimes things just happen by accident, so we always have to try it a couple times. Do you mind?
Yeah.
You'll be okay? All right, let's try this. Did you see anything?
Yeah.
What did? Flame went out. Okay. All right. Carter.
Missed.
You missed it?
Missed.
Missed. Well, okay. Now I want to do it again because I really like to do this. Okay? And let's watch for the mist that Carter saw. You ready? Ooh, that one didn't go out very well, did it? So it's a little different every time. Okay, now, here's why I did that. Because I figured maybe we've got hydrogen and oxygen coming out of here, right? So I figured we'll just take this. We'll go ahead and see. We'll test this the same way we test the gas. Okay, you ready? All right, are you ready? Maybe you should back up a little bit. Just a little bit. Okay. Ready? You're going to observe now, right? You see anything?
No.
No? Nothing? What did you see? You must have seen something. It disappeared. The flame just went out. Did you hear anything?
No.
I didn't either. I'm glad to hear that because I hadn't heard a thing. All right, so that wasn't as exciting, but it was certainly good information. Now I want to do another experiment. This is experiment number 2, okay? And in this experiment, what I want to do is Vinnie is going to take the pot off. You can see it's boiling. I'm going to take this balloon, okay, ordinary balloon, and I'm going to put it over the mouth of the top, the pot here. Ow. Don't do this at home, okay? Now what Vinnie's going to do is put it back on, and I want you to very carefully watch and see what might happen to that balloon, okay? What? What do you see?
It's going to
pop.
It blows up.
Oh, it is kind of getting bigger, isn't it?
It's going to pop.
You think so?
Yeah.
You want it to?
No.
Oh, okay. Well, let's wait and let's see. It is getting bigger and bigger. Well, you were right. Wow.
Do it again.
Do I look surprised?
Do it again.
Isn't that the cool thing about science is that you never really know, do you? I happen to have another one here, and let's try it again. All right.
Oh. It's going to pop.
Is it on? Okay. All right, now we'll do the same thing. What do you think? It's getting bigger. That's right.
It's going to pop.
This is what happens in science, too. I want to tell you a little secret. You know, it always looks like these things always work, but now you know the secret. Sometimes they don't. Sometimes you're surprised as well. You think so? All right. Okay, well, maybe I should take it off.
No.
Yeah, I know. Okay, I'm going to take it off. It's quite big. I'm going to take it off because I don't really want it to pop. I only have this other balloon. And now what I'm going to do is I'm going to put it in this cold water. Okay, here we go. I want you to watch and see what happens. Cold water. You all watching? What do you see?
Smaller.
Is it? Is it getting smaller? Okay.
Ew.
Oh, I don't think it's that small. Do you? I don't think it's that small. It looks, no. Yeah, that would be something, wouldn't it? That's a good idea. Okay, so that was pretty cool, wasn't it? Oh, Vinnie wants to know why that happened. Would you like to see why that happened? Well, you know what? I'm going to have a hard time. I'm going to have a hard time because remember, water molecules are so small you can't see them very well. Remember? And it's really hard. It's really hard to talk about water molecules because they're so small, right? And I know Vinnie gave me this really great model, and it was great. Except the whole thing of water is action. There's action involved. And so, Vinnie, this isn't going to work. I need something that's big, and I need something that we can have some action going on. So, I'm sorry, you can't. Vinnie, are you okay? Oh my gosh. Do we got something that's big enough?
Yeah.
Can it move? Okay, what does this O stand for here? Everybody tell me. Oxygen. Come on, grown-ups, you can do it too. And what are these H's for? And what are the bonds in this molecule? His arms. That's right, his strong arms. Okay, so we have a water molecule that can move around. I think actually, we can't have near as many as that are really here, but we would like to have some more water molecules. So I was wondering if anybody here would mind helping us and being a water molecule. Dixie, you're on. Carter. Who else? We need some more water molecules. Anybody? Anna? Zizi, come on up. Okay. How many? We have 5? Okay. So 1, 2, 3, 4.
5.
5 now. 5 now. Oh, maybe not.
Ansel, you want to go?
Come on up. Okay, now, we need some water molecules. Go ahead. You want to? You don't have to, but you can. Would you like to be a teapot? Okay, we need 2 kid teapots. I need another teapot. All right, that's fine. I need grown-up teapots then. Grown-up teapots. Great. Abby, wonderful. Great. Kristen, I need another teapot. Short and stout. You don't have to be. Great. Okay, come on up. Come on up, teapots, water molecules. You're on my rope. Okay, so a teapot, I need you to stand right here. Thank you, right here. Another teapot. Back over here. You can come here. You want to hold the rope for me? Okay, excellent. Stand right on this X. This is what actors do. They stand on X's a lot. Can you hold the rope? Oh, good job. Great. Now, Abby, you're in the front here. Okay. And water molecules, the teapot's going to move in, so you got to get in there. So Vinnie will show you. Go on in there. Go on in. Water molecules, get in that pot. Okay, now, have I mentioned the part about the dancing? Wow. When water molecules are in water, what they do is they dance, okay? They vibrate. Okay, come on, you guys. Can you do a little vibration? Very good. They rotate. They do this all at the same time. Rotate. Come on, water molecules. And they move short distances because they're kind of jammed in there. They can't move very much. Okay. Now, here's a question for you all. What do you think happens to their dancing when the water heats up? What do you think happens?
Dance fever.
Dance fever. We get faster and faster. So when you're looking at the water molecules, they'll show you how hot they are by how fast they're dancing.
What does rotate mean?
Rotate means go around, okay? So let's see it again. Water molecules, let's do a little practice, okay? Vibrate, let's go, rotate, come on, all right? And dance faster, good. Come on, Anna, come on, you guys gotta rotate. All right, now they're gonna be going so fast, go in circles, that we're gonna get to the boiling point. Yes, the boiling point, and at the boiling point, okay, one by one, they're going to come out of the pot, okay? So one at a time. Anna, you go out of the pot first. Okay, Zizi, now you come out of the pot. You got to keep dancing, keep dancing, keep dancing. Coming out of the pot, good, good. No, well, probably not. Wait, what does he have here for me? Oh, no, you know what? I don't have a model for the balloon. Okay, water molecules, please go back in the pot. We need a balloon. We have the pot, we have the water, but we don't have a balloon. I don't know what we're going to use for the balloon. What? That's your box. That's not my box. I don't really want to. If I don't come back out, okay? Tell my mom. Whoa! It's a balloon model. Look at this. You really have to hold this tight.
Whoa!
Whoa, we got a balloon. Don't let go of this.
Okay.
All right. We got a balloon and it expands just like balloons do. So now we can go ahead and do the little performance, all right? So water molecules, are you ready? Teapots, are you ready? Okay, audience, are you ready? Yes. All right, start the music. Ladies and gentlemen, welcome to the dance of the water molecule. Here we have water molecules. They are vibrating. Good job. They're rotating, and they're moving short distances. Turn around. Right. Now, aren't they beautiful? Now, if you listen carefully, what's happening to the music? Okay, it's getting faster because they're heating up. So, water molecules, you got to dance faster. Come on, let's go. Dance around. You got to dance faster. And after a while, they're going to be dancing so fast, we're going to get to the, tell me, the boiling point. That's right, and we'll need boiling music then. And one by one, you first, Anna. Okay, Zizi, now you can come out. Okay, Carter, come on out. Okay, come on out, come on out, come on out, guys, we're coming out. We're coming out. Whoa! Whoa, whoa, stop. Whoa, Vinnie, what is it?
The balloon's gonna blow.
Remember when we thought it was going to blow? Remember? What did we do then? Not the one that popped. What happened when we thought it was so big? What did we do then in the experiment? We put it in ice. So if we put it in ice right now, what should the water molecules do?
We should go right back in.
That's right. And so to do this, I forgot I had a microphone. To do this, we're going to run the water music backwards. Let's go. Go back in. There we go. All right, here we go. Back in. That's good. Excellent. Go back in the pot. Good. Now, should I stop right here? Did the balloon stop right here? No. Okay. You guys did great. Thank you so much. Let's have a big round, thank you. Let's have a big round of applause for a water. Come on out. Come on out. Take a bow. Take a bow. Okay, and can you give and the teapot molecules, no less important. Teapot molecules, take a bow. Thank you. Thanks so much. Thanks for being a good sport.
There you go.
Now, it was pretty, I hope that was helpful. Was that helpful? Vinnie, what? What?
Kind of.
Kind of. We'll see. Oh, Vinnie says he changed his mind about his answer. Did anybody else change their mind? Well, I don't care if you did or not. I'd like to know what you think after we did our experiments and after we did our models. So will you take out your blue ballot now? The one you've been sitting on so it's nice and warm. Take out the pencils. There it is. And would you put your name, your age down, not your name. And if you're a boy or girl, well, that's perfect.
You already did all that.
Well, just fill it in.
There.
What do you think happens to water when it boils?
I don't know.
Well, didn't we do some experiments? What do you think the water molecules do when they boil?
Faster and faster.
And then what happens?
It goes back.
Yeah, so which one of these options do you think?
I don't know.
Well, think about it. Did they disappear? Did they spread out? Did they break up? Or I don't know.
Spread out.
Well, that's what you think. That's what I want to know.
They did that.
The choices are they disappeared, they spread out, they broke up, or you still just don't know. That's always okay to say that. And maybe we could get a ballot box here. Thank you. Okay, so another vote. You got to vote twice. Most grown-ups didn't get to do that.
Not legally, anyway.
Let's do that again.
Yeah, I know, that was fun. So Okay, thank you. Thank you for voting again. That was great. Now, Vinnie says he still doesn't know. So let's actually go through the options and let's see which one makes the most sense given what we saw in our experiments. Okay, let's see. Now, you know, water goes down when it boils. So do you think the water molecules just disappeared?
Spread
No?
out.
Why don't you think they might not have disappeared?
Spread out.
Okay, well, no, answer the question. Why do you think they didn't disappear? Dixie?
Because,
They just didn't, right? Why? Well, let's let you know what happened in our model. Did they just disappear? Did you guys that did it?
no, we spread it out.
Oh, you did, and you didn't disappear. And imagine the trouble I would have been in if you had, right? Right? Forget this taking pictures without permission. You know, if you disappeared in my pot, just imagine how bad that would be. So no, they didn't disappear. What about breaking up? Do you think they broke up so they made hydrogen and oxygen?
No.
Why not? Dana, why didn't you think that happened? Can you give us an answer? Can you try?
Because they kept holding up their H's.
Well, that's true. These guys, we did not rip off arms and legs, right? Right. And remember when I did my experiment with the H2, with the hydrogen and the oxygen? We got that big, make that noise for me, boom, right? Did that happen when we did the teapot?
No.
No. So they don't break up, although I need to tell you a secret. A lot of grown-ups think they do break up. They do think they break up, so now you know.
No, 'cause that's the last one.
That's the last one. That's a very good test-taking strategy. And they did spread out just like in our model, right? So you're right, they spread out, but all of them were good ideas. We almost had to do some experiments to figure that out, okay? And we did the experiments, we did 2 experiments, and that's how we found out. But you want to do another one. Okay, so do you have time? Do your parents have time? Can we do another experiment?
Yes.
Yes, okay. Yes? Okay, I don't really know what we might do. Do you have an idea?
Yes.
Oh, it's the can. Okay, I know what we're going to do. And the box and Vinnie say that we need to predict, because that's what scientists do. After they think they have a model that works, what they do is they use this model to predict. So here's what I'm going to do. I'm going to put my goggles on, okay? And I'm going to put some water in here, or Vinnie is. And I'm going to boil that water. And you'll tell me when it's boiling. And here's what I'm going to do after, and I want us to predict. Now, have you seen this experiment before, grown-ups and children? What you do when you think what's going to happen is not really predicting, is it? So, if you know what's going to happen, then don't tell me. So what I'm going to do is I'm going to take this cork. I'm going to take it off once you tell me it's boiling, once you see it, okay? I'm going to put the cork in the mouth, and I'm going to put it in the cold water. So I want you all to think, what do you think might happen? Just predict. Doesn't matter if you're right. I just want you to think about it and tell me. What do you think, Zizi?
Pops out.
She says it's going to pop out. What do you think, Dixie?
I think that there's going to be a lot of smoke coming out.
A lot of smoke coming out, even though there's a cork on it? You think around the sides? Okay. Allison, what do you think?
Pop out.
Oh, another pop-out vote. Anybody have a vote? Yes.
It's going to
It's going to pop is a very popular one. What do you think?
out.
Pop out. Okay. How about grown-ups? What do you think?
Tight. It's going to suck in.
Oh, it's going to suck in, says somebody. Okay. Any other grown-ups? Chemistry students? No, never mind. I don't. All right. So soon the water's going to boil. Is it boiling yet? You know what they say about the watched can? Is it boiling?
Yeah.
All right, so I'm going to take this off. Why am I using these?
Because you don't burn yourself.
I know, I don't like that. I'm going to pull it off. I'm going to put it in really tight. I'm going to put it in here. It's not popping off, although I'm putting my hand up in case it does.
It's sucking in.
It did not pop off. Whoa, it sucked in instead. And that was a pretty strong can. Now, would you like to know why that happened? Well, you know what? We're out of time. But you guys could go to our website, and not only will you see an explanation of why that happens, which you can get your mom and dad to help you read, but there's another experiment. Do you have soda cans at your house?
Yes.
Okay. If you don't have any soda cans, you'll have to go to the neighbors and borrow them, or make your mom and dad buy you a can of soda, right? Which you will conveniently drink. And then you can do an experiment just like ours. So go to our website, and the website is www.fusionsciencetheater.org. Can you say that with me? www.fusionsciencetheater.org. Okay? So go to our website, and you'll see an experiment to do. Okay? So it was really fun. Hey, so did you enjoy it? How many people like science now? Raise your hand if you like science.
I always wanted to be a scientist.
I'm glad to hear that. I'm glad to hear that. Oh, Vinnie, we got to go now. Enough. I know. Okay, ready? Science in a box, science in a box. Our show is done, we've got to run with science in a box. Thank you so much. Thank you. Thanks for coming. You can have that pencil, okay? Thank you for coming. Yes, you can keep the pencil, okay? Oh, and so Joanne, because this is sponsored by the National Science Foundation, and we're trying always to improve and make things more engaging and more educational, Joanne, our evaluator, has questionnaires for kids and grown-ups. And believe it, we would really love to hear what you think.
Can every grown-up,